Hi everybody, myself Sankareswari, Assistant Professor of Physics, PV Vanniya Perumal College for Women, Virudhunagar. So now I am going to explain about solar dryer and solar distillation. First let me explain what is solar dryer. Solar dryer helps to preserve food product by removing the moisture content. Solar crop drying is the most ancient and direct use of solar energy. The material to be dried is spread as a thin layer on the ground. But there may be many disadvantages in this method. The process is very slow, the product is vulnerable to attack by insects, and dust gets mixed with the product. The use of solar dryer helps to eliminate these disadvantages. Also, drying may be made a faster and controlled process and a better quality product can be produced. A simple cabinet type solar dryer is shown in the figure. First, the solar radiation is received by the transparent cover and it may consist of perforated trays in which the products are placed and air is allowed to let in and let out. So the solar dryer consists of an enclosure with a transparent cover that is similar to greenhouse. The material to be dried is placed on the perforated trays. Solar radiation enters the enclosure and is absorbed by the product as well as the surrounding internal surfaces of the enclosure, increasing its temperature. The inside air heats up to a temperature ranging from 50 to 80 degrees Celsius and rises above. Natural circulation of air is ensured by providing suitable openings at the top and bottom. The circulating air removes the moisture from the product. For large scale drying, forced circulation of air may be used by employing a blower. For products where direct sunlight is not adequate, controlled temperature drying known as kiln drying may be used. Here the air is heated separately in an array of solar air heaters and then ducted to the chamber where the product to be dried is stored. Such dryers are suitable for food grains and products like tea and tobacco. Next, solar distillation or desalination of water. So potable or fresh water is one of the fundamental necessities of life for humans. Industries and agriculture also require fresh water without which they cannot develop well. Humankind has been dependent on rivers, lakes and underground water reservoirs to fulfill the need of fresh water. Because of rapid industrialization and the increased population, the demand of fresh water has increased enormously. The average per capita consumption of water has also increased with the rise in the standard of living. Due to climate changes and less rainfall, the fresh water which was available from rivers, lakes and ponds is becoming scarce. The available resources are getting polluted due to discharge of industrial effluents and sewage in large quantities. Thus, due to climate change, the pollution and increased consumption, more than 2,000 million people have no regular access to adequate safe water. In some villages, people travel up to 30 km to collect fresh water. About 79% of water available on the earth is salty. 20% is brackish, that is less salty water, which is collected from wells, and only 1% is fresh. Conversion of brackish or saline water to fresh water through the distillation process using solar energy is a good idea where plenty of saline water and sun are available. The use of solar energy for desalting sea water and brackish well water was first applied in 1872 at Las Salinas, Chile, in a plant supplying drink water for animals working in nitrate mining areas and for transport. The conversion device is known as solar still. Several types of solar stills have evolved. The basin type solar distillation has been tried commercially on a large scale. A simple solar basin type solar still that consists of a shallow blackened basin filled with saline or brackish water to be distilled. So the construction of the solar distillation plant is shown here. The brackish water is filled in the basin, and the solar radiation is received by the transparent layers, and then that salty or brackish water may be converted into fresh water, and it is collected through the channel. So here the depth of the water is kept about 5 to 10 centimeter. It is covered with a slopy transparent roof. Solar radiation after passing through the roof is absorbed by the blackened surface of the basin and thus increases the temperature of the water. The evaporated water increases the moisture content, which gets condensed on the cooler underneath the glass. The condensed water slips down the slope and is collected through the condensate channel attached to the glass. The still is erected in an open area with its long axis facing the east-west direction. The still can be fed with the saline water either continuously or intermittently. The supply is generally kept at twice the rate at which the fresh water is produced, but may vary depending on the initial salinity of input water. The output of a typical solar still in Indian climate varies from 5.31 per meter square day in summer to 0.91 meter square day in winter. Thank you.